Hello all, welcome to the video lecture series for the subject database management system. Today I am going to explain you all about what is concurrency control in database management system with a fine example. Basically, the database management system concurrency control is a mechanism in database management system, right? And it allows simultaneous execution of a transaction with the existing and which is going to be a proposed one. Basically, this is an execution while maintaining the ACID properties, right? So the concurrency control is always depends on ACID properties, which I have been already explained when I am talking about transaction control, right? So basically, it maintains integrity, accuracy, and reliability. All right. So here the atomicity, consistency, isolation, and durability, which includes this integrity, accuracy, and reliability. Right. So when this concurrency control is needed, that is a point. Right. So here, when a multiple user or multiple process perform read and write operation concurrently, that is the process, right? When this process is adopted and all the operation concludes, there is a need of concurrency control. Okay, so here comes, what is this concurrency control helps in? There is a big question mark, right? Basically, it helps in conflicting operation on shared data. So basically, here comes the process. What is the conflict in shared data? That is an update. If the update is inconsistent, which the database has been shared between, for example, A and B. A is reading a shared data and it is updating. B is reading a shared data and it is updating. Okay. When A completes and B reads, there is no conflict. If A and B reads the shared data at the same time, there is a conflict. We are going to see this with one case study as well. Okay, right. What is the second concurrency control helps in? It helps in inconsistent database states. Okay, it is the dependency of the conflicting shared data. And finally, it may refers, right? If there is no concurrency control, it may have lost or incurrent updates on the shared data. Okay, so these are all the three important points, right, where we need to know why this concurrency control is very essential in database management system and also the transaction process. So you can have a note, right? By implementing this concurrency control, the techniques such as locking or timestamp ordering, database always ensures that the transaction are executed very safely and independently, even when they overlap in time. That is a point. Okay, so I'm going to show you with one basic example where you are going to see that where there is an overlap in time and how this independently and safely this process has been executed. Okay, right. Let me take you to this fine example, that is need for concurrency control, right? So now you can raise a question, right? Basically, why this concurrency control is needed and what is the need of this concurrency control? Basically, it prevents what? So what we have listened from the previous one, that is, it prevents conflict between simultaneous transaction. That is the main important point. It prevents conflicts, right? We'll see what is the conflicts one by one. Basically, here I have written the scenario as A and B are doing this transaction simultaneously. And what happens if there is a concurrency control? What happens if there is no concurrency control? There is a concurrency control with concurrency control, without concurrency control. It's very simple example. The classical way of understanding how this concurrency control is actually working, right? So initially, both A and B are reading. Okay, so initial balance they reads 1,000 rupees without concurrency control, and B reads both with concurrency control and without concurrency control. There is no change, right? This is perfectly done. Let's have this. Now A is reading the data, that is 1,000 rupees, and withdraws 200 rupees from it, and the new balance became 800 rupees. I hope you understand. This is without concurrency control, right? Now with concurrency control, now again it reads the data, That is, it withdraws the data 200 rupees and the new balance is 800 rupees. This is after the transaction of A. Okay. Now imagine at the same time, the timestamp. Let me write timestamp. Both are same. That means simultaneously the database is accessed. This is A user and this is B user. Now what happens if there is no concurrency control, that is without concurrency? Okay, what happens if B withdraws 300 rupees, okay, and it reads the balance as 1000, but the actual balance is what? 800 rupees. So that is the point here. We need to know, without concurrency control, again B is doing same simultaneous transaction, right? So balance should be same. So the balance, it reads 1000 again, and the new balance will become, because here it is withdrawing 300 rupees and it will read the balance as 1000 rupees. New balance will become 700 rupees. This is without concurrency control. There is no commit and no wait for the transaction. Now you can see here, with concurrency control, the concurrency control identifies that already there is a user with begin the transaction, and already the second user is also approaching the reading the transaction, want to do a transaction and reads the same database. Then it is wrong. So what it will identify, it is someone is already executed, someone already is in execution. It will wait for the existing transaction. That is, who it is waiting for? It is waiting for A, which has been already, transaction has been started. After milliseconds of time, B initiate the transaction. So what it is now, B reads the balance as 800 rupees. I am talking about with concurrency control. How it happened? Because already A have been initiated, that is withdrawal of 200 rupees, the balance is 800 rupees here. So if B want to transmit a data, that is withdrawing an amount of rupees 300 rupees, then it will check the balance as 800 rupees only. It is not 1000, right? So that is actually called as with concurrency control. Why? How it is reading it as balance as 800? Because it is waiting for someone who is already in transaction. The transaction is not yet completed. So after waiting for that particular transaction, it reads, that is 800 rupees as a balance. And what is the withdrawal amount of B? It is withdrawing 300. So 800 minus 300, the new balance becomes 500 rupees. That is the point, right? So what I am talking about, it is with concurrency control. Here you can see that without concurrency control, right? So what happens here exactly? It waits for the transaction of A to finish. Once A commits, okay, and read the updated balance as 800 rupees. That's the point. But here in without concurrency control, there is no wait for the transaction of A, and B begins the transaction, and there is no commit process has been adopted here. So that is the difference between without concurrency control and with concurrency control. Now you can check the final updates here. Now A writes, okay, so A writes, that is 800 rupees as a balance, okay, and B overwrites that by 700 rupees. I'll explain you, because this is without concurrency control. See here, initially A writes new balance as 800 rupees. After this, B is doing what? It is doing same thing, and it withdrawn 300 rupees, and the new balance is what? 700 rupees. So there is a conflict between these two, correct? So there is a loss of update here. Now where is coming at here exactly in this point? A writes the balance as 800 rupees and B writes the balances as 500 rupees, correct? So totally we have done the transaction from 1000. A withdraws 200, B withdraws 300. So totally 500 rupees has been spent. So what is the final updates here? It is 500. You can able to understand now, I guess, right? So the final balance you can check here, that is without concurrency control. This particular column is without concurrency control. It is finally updating it as 700 rupees, and you all know that it is incorrect, okay? And here you can find it as 500 rupees, and this is actually the current state, right? Because A is initiating to withdraw 200 rupees, B is initiating the withdrawal 300 rupees and the total is 500. What is the balance? Initial balance 1000 rupees. Right? I hope you understand now. So here what exactly happens is maintain the data. If what is the need of actually concurrency control, it maintains the data consistent and accuracy in multiple user environments. This is A, this is B. You can see the multiple user environments. It avoids the problems such as dirty reads and also lost updates and also inconsistent read. Okay, so you can see all this dirty, there is no dirty read with concurrency control, and there is no inconsistency, there is no non-accuracy, there is not preventing any multiple user environment. It is allowing everything, and it is showing, it is avoiding the problems such as dirty reads, lost updates and inconsistent reads of the data. Okay, so without concurrency control, for example, two users update the same record simultaneously and one update overrides the other. That is what I have shown here. Okay, A and B are the two users. With concurrency control, you can check here. A database management system user locks or timestamps to ensure the update, okay, occurs sequentially and data remains very perfect and very correct. You can able to see that. Finally, this is the result, right? So there is a concurrency problem in database management system. Only three important facts you can do. That is dirty read, lost update and inconsistent read. Okay, so this is the simple absorption of the data transmission over the network in the concurrency control. And what happens if there is no concurrency control? What happens if there is a concurrency control? I hope this will make you understand why we need a concurrency control in a database management system. Thank you.